This process is called double immunodiffusion, whereby the antigens and antibodies will diffuse towards each another simultaneously. At the point of equilibrium, precipitation forms, showing that there is interaction between the antigen and antibodies.
Now to explain the immunoprecipitation curve. Firstly, we need water, representing your antibodies, and fruit salt, representing your antigens. In this situation, the antibodies are in excess amount, whereby the fruit salts are in small amounts. As you can see, there is minimal precipitation as the antibodies are unable to form lattice formation. Now to a situation whereby the concentration of antibodies and antigens are similar or equal. Now you can see that there is a lot of precipitation as the antigens and antibodies are able to form a lattice formation. And yeah, in this situation there's insufficient antibodies but excess antigens. There would not be any precipitation as there is no lattice formation formed. Okay, this is the explanation for monoclonal and polyclonal antibodies. This adapter represents our foreign particles or foreign antigen. It has many plugs on the surface, holes on the surface, and it represents the epitopes on the surface of the antigen. This represents our antibodies. So these are the adapter sites or binding sites to the epitopes, and there are many. Our body can produce many different antibodies of different binding sites. So in a monoclonal situation, our bodies will produce one antibodies that are specific to one epitope on the foreign particle. In a polyclonal antibody situation, our bodies produce multiple antibodies that are specific to multiple epitopes on the antigen.
We need to find a mouse to inject the antigens. There's a mouse! What? Yeah! Let's drag the mouse back to the lab. Come. Let's go kill the mouse. Come. Follow me. The mouse is over there. Go. Hi mouse, I'm here to kill you! Ha! Look at my knife! It's only this. I've got your spleen! This is the spleen of the mouse that we've just killed just now, and now we're gonna cut up to get the spleen cells. These are the spleen cells that we get from the spleen. These sweets here represent the spleen cells of the mouse. This is the PEG solution. And in the PEG solution, the white Mentos represents the myeloma cells, and the red heart sweets represent the spleen cells of the mice. In the PEG solution, they are being fused to form a fusion cell, also known as the hybridoma. The white streaks here represent the myeloma cells, and the red streak here represents the spleen cells. And now we're going to cultivate the myeloma cells, spleen cells, and also the fusion cells, which are represented here by the gummy bears, in this, which is the head solution. Now we're going to cultivate them. Time, the myeloma cells would totally be destroyed, leaving only the spleen cells and also the fusion cells. The spleen cells will still stay in the head solution, but after another period of time it will slowly die off, leaving only the fusion cells. Now that the surviving cells are collected, antigens are added to these cells to test for antibodies. The fused cells would produce specific antibodies that destroy the antigen. These cells are then collected and cloned to produce the monoclonal antibodies.